Hey everybody, this is Larry. This is me doing day 5 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Arranging coins, and this is an easy problem according to them anyway. A lot of downvotes, but anyway, yeah. We'll be doing this all month, so join me on Discord. Post your code. Let us know how you think about this. Anyway, you have n coins and you build a staircase with these coins. You have k rows. Return the number of complete rows of staircase you can build. Okay. I don't know why they say rows and then these are columns, but or am I just like confused? Okay. The I row has exactly I coins. Why would you build it this way though? Would you not just build it like 1, 2, 3, or like we have 8, you have 1, 2, 3, and then 2, right? Or am I missing some nuance here? Oh, I think these. Maybe I'm just misreading this. I am totally misreading this. So I thought that they're filling out the columns, and actually it does kind of fill my hypothesis. But actually, they're from row down from top to bottom. That's why. Okay. Yeah, I mean, I think this is just a for loop. The thing to notice is that the sum of the first n numbers is going to be, roughly speaking, n squared. You can do some math with that if you really like. But you can also just means that this will 1 and 2 to the 16, which, as you know, is 64,000. I think I got it right this time, and not 32,000, because I keep. Wait, is it? I think I'm confusing myself a lot these days. Yeah, 65,000, 64,000 ish. So yeah, so that's gonna be good for a for loop. Yeah, I mean, you can also do another way where you do a binary search on this as well, or bisection, which is just that you have this formula, x times x, x plus 1 over 2, or maybe x minus 1. I always mix those up. But yeah, now this will give you the number of coins, and then you can just do a binary search on it. And then another way to do it is just solving this algebraically. I'm really bad at that, or at least I'm really. Actually, maybe we could do that. Let's. I am really bad at it generally, but so you may see some. Maybe this is embarrassing, but yeah, let's try to do that and then figure it out. Because I was going to say that rounding errors is an issue, but we can just play around. There are ways to get around it, and we'll show you in a second, maybe. I like my ends to be big, so let's go. So let's just say, and let's see. So the first row will take 1, the second row will take 3, the first row 3, right? So what is this? This is I'm just, to be honest, and this is maybe embarrassing, and that's fine because I'm just showing people how it's done, even sometimes me, which I guess I'm just bad at math. So yeah, so this is 1, so that means that 1 times 2, okay. So 2 times 3 over, okay, so this is right, so 3 times, okay. So I just want to make sure that this form is correct. I mean, I know that this is roughly correct, but sometimes I mix up with this. Maybe I need a better way of thinking about it, but yeah, so this formula is correct, right? So now, and I would probably do this on paper, but you have some n, you want to get, so you have some n, you want to get the largest x for which this is true, right? So then now we just solve for it. 2 times n, and then now you can say maybe square root of it, and then we could play around this formula, right? You could solve this also more directly, maybe, right? And note that n is a given number, so you can actually solve this by x squared plus x minus 2, and then just do the quadratic equation, maybe. But I think we can also just be a little bit lazier, because then now this is just actually, like I said, plus x. So then now we can take the root and then look at a number or 2 after that or before that or whatever. And maybe we could just do the quadratic equation actually. because basically now you have some. Yeah. Okay. Maybe. Yeah. I don't remember the quadratic equation, to be honest. But which is kind of embarrassing, right? Because I always look it up nowadays. It really is not something that you need to solve, or you need to. It's not something that come up that often. So actually, I'm not gonna lie. Right now, I just plugged into Wolfram. Let's see if that gives me the. Oh, how that. So now we find n such that this is the case, and then we can find the int that makes that true. Doesn't Wolfram let me do this anymore? I don't know. Maybe I'm doing it wrong. Oh, I have double division. Maybe that's why. Whoops. Yep. So then this is, then n is equal to, wait, I know, I think I meant to solve x. How did I solve for, okay, input result, okay, but I don't know how to use Wolfram, clearly. Solve x. Okay, there we go. I had to write solve for x. Anyway, so yeah, so then x is just equal to, according to this formula, 1/2 times the square root of n plus 1 minus 1. Okay. That's basically what you would get if you solve for the quadratic equation. I'm guessing the other one. I mean, there should be two roots. Oh, I actually misread this. Yeah, so there should be two roots. There's also the negative version of this, but I guess that would be a negative number, so it doesn't really make sense. So I think this is quite good. Yeah, and you can actually do this manually. So yeah, I think if I was doing on a contest just for full disclosure, I probably would have either wrote a for loop if I think it's fast enough, or binary search, which is definitely fast enough. But you know, I'm here to learn as well, even on easy problems. Like there's no, I mean, easy problems are the easiest to learn because then you can isolate the things that you're bad at. And in this case, I do have, like I said, yeah. So then here we can write x is equal to, let's just say square root of n plus 1 minus 1 times. Okay, so then now we have, let's see. Do we just round down here? I think we just round down is fine, right? No. Oh, wait, I'm missing an 8 somewhere. Okay, yeah. Oops. It's like, this is really off. But apparently copy and paste is also hard skill, so I think now we can just return the int of this, and we should be good. Because now we're round down. I think the only thing that I may worry about with these things in general is the thing that I worry is that no, we have, this may give you like on exact numbers. There you go. Huh? Why am I off by 1 here on a lot of things even? I mean, I do worry that, like I said, like that there'll be rounding errors. I think that's the issue that I worry with, which is why this is why I said at the top of the show or the video that I generally don't like doing this because yeah, there might be rounding errors. And in this case, there are one. Let me try to think in terms of interpretation, right? Why is that true? Unless I'm, Maybe I have a typo. Let me double check my formula. It's 1/2 of this thing. Man, wow, I'm really bad at just copy and pasting the form, or not copy and pasting, but look at the formula and implement it. That is pretty embarrassing actually. But now we're good again. I'm just jamming in random numbers. The thing is that I am still worried about that position though, even though that turned out not to be the issue. But it is good for me to kind of it is good enough for me to give it a spin. So it looks good. So let's give it a spin. Oh, I did it in a lot of ways before. If I have to guess, I would guess this is the for loop, and this is maybe the binary search. Let's see how I did it. Yep, I did it in a for loop, and this one I did do in a binary search, so I was correct. And so I did do something new before, and what did I do in C way back when? Okay, I also did a for loop, but it's just much faster in C. Okay. Yeah, that's really all I have. This is going to be all of one-ish if you want. The reason why I said ish is because if you want to take the in size as the number of bits, then technically the square root function also operates as a function of the length of the bits, or number of bits that the number represents, and therefore you can maybe say that this is linear, but I don't know. But linear in the size of the input, which is the number of bits. But I'll just say for the easier sake that this is all of one. But yeah, that's all I have. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great rest of the week. Friday's coming up, or maybe Friday's here, depending on when you watch this video. So let's have a great weekend as well, and I'll see you later. Bye bye.